Hello, so today's topic is indices, surds, and logarithms. So first of all, let's look at some rules set aside for indices and surds. So first of all, any number having the power 0 will be equal to 1. Obviously here a is not equals to 0 because 0 to the power 0 is undefined. So anything having power 0 will be 1. Okay, now if something has a negative power, that means that the reciprocal of it will be equal to the reciprocal of the number having that power. So if there is a to the power minus p, it will be equal to 1 upon a to the power p. So for example, I say 2 to the power minus 1, you can call it 1 upon 2. Okay, so if a number has a fraction, so that means that that number is being that many times rooted by that number. So for example, I say that 4 to the power half, this will be equals to root 4. Okay, now if there are two numbers, so first we will put a root, and then we will put the value which is either the square or cube or whatever. So for example, 4 to the power 2 upon 3 will be equals to 4 under root cube under cube root, and then being squared. Okay. Now if two numbers are being multiplied and their bases are same, like in this case a and a, so both the numbers in the power will be added, and it will give us the a to the power m plus n. Similarly, if two things are being divided, both the numbers in the power will be subtracted. So in this case, a is same, and the answer is a to the power m minus n. Now if there's a number and it has a power, and the whole thing has a power, for example a to the power m has the power n, so the answer will be a to the power mn. Both of these will multiply. Okay, if two numbers are being multiplied but their bases are not same, we can take them as common. So basically ab will multiply to the power n. So when opening this bracket, the power applies to both these numbers, so it will again come to the original form, which was this. Okay, similarly in division, we can again take it common, because in division, when you open this bracket, again it will give you the result a to the power n upon b to the power n. Okay, so now that we've discussed these questions, these examples, let's move forward to some questions. Okay, so for example, in this question, they've given us this to simplify. So we will use the rules we learned in previously. So first of all, we will simplify this. So 3 into the power 1 upon 3 into 3 to the power 0 into 3, because 3 is 9 is 3 squared, so we can take this as 3 squared, and to the power 1 upon 3. And because 27 is 3 to the power 3, so we can also take this as 3, and this has the power 2 upon 3. Now if we simplify this 3 gets cancelled with this 3, because remember when this had a power, these two powers multiplied. Similarly with this one, it will multiply, and this will give us the result 3 power 1 upon 3 into 3 power 0 into 3 power 2 upon 3 to the power 2, because 3 and 3 got cancelled in this one. Okay, now we discussed that if three of the bases are same, so their powers will add. So 3 to the power 1 upon 3 plus 0 plus 2 upon 3, this gives us 1, and 3 to the power square. So 3 upon 3 square, and this 3 gets cancelled with this square, and this gives us 1 upon 3. Okay, so this was the answer for this one. Let's move forward to another question. Okay, so this is a question given 8x square to the power 8 minus r into 1 upon 2x to to the power r, 2 to the power 24 minus 4r, into x to the power 16 minus 3r. So in this we have to prove that this side of the equation is equals to this side of the equation. So first of all we will ignore this side and we will simplify this side. Okay, so we can write 8 as 2 to the power 3, and because 8 minus r will be applying to both of these, so we will firstly take 8x squared to the power 8, and we will divide 8x squared to the power r, because we learned that if something is in minus in the power, that means that it is being divided. Okay, so 8x square to the whole to the power 8, and it being divided by 8x square to the power r. That's what we've done in this part. So 2 to the power 3, that being 8, into the 8 which came from here, and this being multiplied into x square, and then being having the power 8. Okay, and it being divided by 8x square to the power r, and 1 upon 2x to the power r will apply to only 2x, because 1 to the power anything is 1. Okay, so we will simplify this. So we get 2 to the power 24 from here by multiplying 3 and 8. We get x to the power 16 by multiplying 8 and 2. Down here we get 2 to the power 3r, because again 8 is 2 to the power 3 and r is being multiplied by 3. Then we get x to the power 2r by multiplying r with 2, and then we brought this here, this part. So 2x to the power r, so we'll write them separately, 2 into r and x into r, x to the power r and 2 to the power r. Okay, so when we simplify this, we get this 2 to the power 24 into x to the power 16 upon 2 to the power 4r and into x to the power 3r. And now that we bring it up, because it's divising, we put a negative sign in the power, and this gives us the original equation, and we can prove that this side of the equation is equals to this side of the equation. Okay, so one type of question you can get in this is simplify the following. So you'll be given this and you'll be asked to simplify it. Now anything in a square root, if there is this, so you can write it as root xy. So the things inside the square root can be multiplied, and again this can be broken down into root x into root y. Okay, so now that we have this, when we have the square root or any root in the denominator, to simplify it, we try to eliminate the square root or cube root, whatever there is, from the denominator and bring it in the numerator, or eliminate it completely if possible. So in this case, we can make this like this, because 5 into 6 is 30. I'm sorry. This can be changed into 12, because 5 into 12 is equals to 60 and root 5. So this can be broken down into root 12. But again, root 12 is not the simplest form, because it is root 4 into root 3, and root 4 is equals to 2. So the answer is 2 root 3. Now you'll say that you can use this in the calculator, but in some questions they'll say that you cannot use the calculator, and you'll have to show these specific steps to show that you haven't used your calculator. But obviously you can use your calculator and cross check if you've done correctly. Okay, in this case we can see that okay, none of them are similar, none of them are being multiplied. So what do? Okay, so we simplify each and every one of them. So we can make this into root 4 into 2, right? Because firstly, when we get a square root, we see that what is the greatest possible square that we can fit in, which is also a multiple of this. So for example, we have root 8. So I say that the squares are of 2 the square is 4, then of 3 there is 9, then of 4 there is 16. So I can fit 4 here, okay, and 4 is also a multiple of 8. So okay, 4 into 2. So we get 4 root 2 minus 4 becomes 2 because it exits the root by becoming 2, and 2 remains inside the root. Okay, 50. Now what can I fit inside 50, which is also a multiple of 50? So I can break it down into 2. Okay, there is 25, there is 49. Okay, so 49 is a possible number I can fit, but okay, it's not a multiple, so scratch that. 25, yes, 25 I can use, that is a multiple. So root 25 into root 2, this will give you root 50, but this will also give you 5. So this gives us 4 root 2 minus 2 root 2 plus 5 root 2. Okay, now that every one has the same base, which, for example, I said 4x minus 3x, so you would say x, right? So these have the same variable, so you can consider these roots as a variable as well. Okay, so this was root 2. Okay, so 4 minus 2 plus 5, you can simply do that. 4 minus 2 is 2 and plus 5, so this will give you 7 root 2, and this is your answer. Okay, now we will often be asked to rationalize something. Okay, so rationalization is that, again, you have to remove the square root from the denominator. So in this case, to remove the root from the denominator, we will multiply it by root 3. So by doing this, we are eliminating the square root in the bottom, but also keeping the fraction the same. So it will become 6 root 3 above, and because when we multiply roots, it becomes it multiplies inside the square root, so this will become 3. So 6 upon root 3 upon 3, and 3 2s are, so 2 root 3 is the answer in this case. So this has now been rationalized. Okay, now let's look at this case. So what can we do to eliminate this root 2 in the denominator? Well, to remove this, we have to square all of this. But if we square all of this, we will get the middle term, which will be 2ab, which will again have this square root. So to eliminate that, we can use the identity, which is a minus b, a plus b, which gives us a square plus b square. So if we do this, we will get this to be 9, and then this to become 2, and this to become 16. So the bottom will be rationalized if we are able to do this. So for this to happen, what we can do is we can multiply the whole thing by 3 root 3 minus 4, 3 root 2 minus 4. This was 3 root 2. Okay, so why are we doing this? Again, a minus b, a plus b will give you a square plus b, a square minus b square. So this is what we're doing. Okay, so if we look at the above portion, this will simply become 3 root 2 minus 4 whole square, and the bottom part will become 9, and this will become 2, and this will become minus 16. So you can simplify this. This might get simplified further if you open the bracket above. I'm not going to do that. This will give you this, and this will be your answer if you simplify it more. Okay. Okay, so what are exponential equations? If two of the bases are the same and they have a certain power, so they can their powers can equate to each other. So for example, I say a to the power x is equals to a to the power n, so you'll say that x is equals to n. But this does not apply for minus 1, 0 or 1. Okay, so for example, in this question, we have 4x is equals to 2 upon 8x. 2 की power 8 upon 2 की power 8 upon x. So you can say 2 to the power 2 into x is equals to the power 8 upon x. This will become 2x is equals to 8 upon x. 2x square is equals to 8, and x square is equals to 4, and then x is equals to plus minus 2. Okay, so that was all from the part 1 of this topic. I'll see you in part 2.